All right, here we are at our weekly SAT question for week 8. We have two equations in standard form stacked together. Looks like a system of equations to me. In the pair of equations, a and b are constants. The graph of this pair of equations in the xy plane is a pair of perpendicular lines. Which of the following equations also represents a pair of perpendicular lines? And we have our, usual multiple choice questions. All right, let's see how we did, huh? All right, if we take a look at our results, there looks to be one front runner, which is this burnt orange B looking thing at 40.9. Rather a low number. However, that one is the correct answer choice B, as we'll see here in a minute. And if you look at the remaining ones, they're almost evenly spread. I don't know if that indicates that this was kind of a guess, or if there were some distractors that were convincing enough to let us know that this looks like that could be the correct answer. All right, if you look at our difficulty level, we this looks pretty firmly in the medium camp. All right, unfortunately, this is not a question that lends itself very well to a Desmos kind of crutch here. So here, I'll just show you. I've already typed these guys in, and whenever you try to type in the second equation, of course, it's going to prompt you to have sliders, because without sliders, it has no idea what A and B are supposed to be. So you got these sliders, and then maybe you try to move these things around so that you can try to get perpendicular lines. But at this point, what's happening is that you're just like eyeballing where you think these perpendicular lines are supposed to be, and there's like an infinite number of places where this thing could happen, right? This would be impossible for you to just play around with in the time that you had in order to figure out what A and B could possibly be, and then compare that to your answer choices, right? So yeah, don't bother. Instead, here's what you need to know. This is from algebra, and it has to do with slopes. We're talking about perpendicular lines, and there is a very peculiar thing that happens with the slopes of perpendicular lines, and that is that they are negative reciprocals. Let me write this down. Perpendicular lines. Their slopes are negative reciprocals, or you may have learned it as opposite reciprocals. Slopes are negative reciprocals. And here's what that means. Let's say, for example, I have a slope of one of my lines, I'll call it slope 1, is 2/3. And then if I wanted to find the slope of any line that is perpendicular to that, what I do is I flip this slope over, and then I change its sign. This one's positive, mine's going to be negative. So the perpendicular slope here is going to be a -3/2. Okay? Now, here's another aspect that's true about the slopes of perpendicular lines. As long as one of them is not horizontal and the other one's vertical, what would happen if I took these two slopes here and I multiply these two slopes together? Here, let's see. So if I take slope of 1, multiply this times the slope of 2, I have 2/3 that I would multiply times a -3/2. When I multiply straight across, top times top and bottom times bottom, I get a -6 divided by 6, and that equals -1. And this is always going to happen whenever you have slopes of perpendicular lines. So another way of saying it, instead of saying their slopes are negative reciprocals, oops, didn't mean to do that. Instead of saying their slopes are negative reciprocals, I could say that their products are equal to -1. Now, again, there's a special case, and that's when you have a horizontal and a vertical line, because a horizontal line slope would be 0, and then its negative reciprocal would be undefined, so it won't make sense in that case. Okay, but that is a special case, and that's not what's happening in this one, as you'll see here in a minute. So I'm going to put a little side note here to say that these slopes are going to multiply to -1. So m1 times m2 is equal to -1. And I think that this is a faster, easier way to solve this problem. You can do it either way by looking at the slopes and calculating what is the negative reciprocal, but I think that it's easier to actually find the slopes and then multiply them and force them to be -1. Okay, now notice that the equations that we have are in everybody's least favorite form, otherwise known as standard form. So here, standard form looks like this. standard, okay, I think I spelled that right, form. The reason why standard form is not all that great as far as finding the slope is because there's no indication of what that slope is supposed to be when it's looking like this. AX plus BY is equal to C. Generally, what you have to do is you have to transform this into another form in order to get what its slope is. And the form that I'm talking about is y equals mx plus b, the slope-intercept form. And the reason why is because once you get it into this form, by isolating the y, whatever the coefficient of your x is, that's got to be what your slope is. So here, let's actually look at this in general. What I mean by that is just let's solve the standard equation ax plus by plus c. Solve this thing for y, isolate the y, so you can see what the slope is supposed to be. And really what I want to do in the process here is reveal kind of a mental shortcut on how to find the slope of a line when you have your line in standard form. Okay, so I'm going to write that ax plus by equals c down again, and I'm going to start chipping away at everything so that I can get y by itself. So the first thing that I have to do is get rid of this ax, which is being added to the by, so I'll have to subtract that thing over to the other side. So I'll have by is equal to negative ax plus c. And now this b is being multiplied times the y, so I'm going to have to divide. I'll divide everything by b, and I can make one complete fraction over here, but I'm not going to. I'm going to basically divide both individual fractions by b. So I have y is equal to a negative a over b, x, plus c over b. And now we don't really care about this. This is the y-intercept. What we care about is our slope, and we've just revealed that slope to be negative a over b. Now, I'm not suggesting that you have this memorized. Oh, whenever I have standard form, the slope of it is negative a over b. But instead, notice how we got it. What we did is that we subtracted the ax term over, and then we divided by the b. It's that process. Subtract over the ax term, divide by the b. Whatever you have in front of your x, that's what's going to be the slope. So here's ours. Ours is 5x plus 7y is equal to 1. 5x plus 7y is equal to 1. And I will step by step do this just like I did here, but then we'll discuss how we can just kind of mentally get what that slope is so we can get it really fast. So I'm going to subtract over the 5x, 7y is equal to negative 5x plus 1, and then divide everything by 7. Y is equal to a negative 5/7 x plus 1/7. The 1/7 here as the y-intercept, who cares? We want this. We want our slope of negative 5 over 7. Now, I don't want to have to do this for all of the equations that are in my list. Look at this. No, Instead, realize that what I had to do here is that we had to subtract over the 5x, that made it 8 negative 5x, and then we had to divide by the 7, so put the 7 on the bottom. So I can really quickly get my slope of my first line is equal to a negative 5 over 7. Okay, the second equation was ax plus by is equal to 1, right? Yes, it was. So I'm going to do the exact same thing here, but this time I'm going to do it mentally so I can speed up the process. I know I have to subtract over the ax term, so it's going to be a negative a, and then I'll divide by the b, so the b is going to be on the bottom. It's a negative a over b. And now at this point, here are the two slopes of these two lines. I can do one of two things. Let's come back up over here to our notes. We can find out what the slope of the negative reciprocal is. And basically what you do is find the negative reciprocal of this one, and then you can set it equal to this. That's one thing you can do. The other thing that you can do is you can just multiply these two slopes together to get negative 1. And I think this is a little bit easier to do. That's the way that we'll look. We can take a look at this other form of this at the end of the video if you're interested. But in the meantime, what I'm going to do is I'm just going to take slope of 1, multiply it times slope of 2, and this should be equal to negative 1. So I have a negative 5 over 7 times a negative a over b. And when I multiply these two, I just multiply them straight across. Yes, there are variables in here. It doesn't even matter. So the two negatives are going to cancel out, make it a positive 5a over 7 times b. This should be equal to -1 for any of these perpendicular lines. Now, at this point, like, you can leave it just like this, or you can try to isolate the a over b if you wanted to, so you can get some kind of formula for what a over b is by just getting rid of the 5, getting rid of the 7. Basically, it would be multiplying by the reciprocal, but you don't even have to do that. What we're aiming for here is this. If we can get this to happen in one of our answer choices, we'd be in business. Okay, now, before we actually do that, there's one of these answer choices that should be an automatic deletion. And the reason why is this. Look at our two equations. 5x plus 7y equals 1, ax plus by is equal to 1. There's something here that looks almost identical to that, and that's answer choice D. The only difference here is that there's a negative in front of the 7 on the 5x minus 7y is equal to 1. But everything else is the same exact bottom equation. That means, remember, whenever we found the negative reciprocal slopes or multiply them to get a -1, this is what it's supposed to look like. It's impossible for D to look like that because they switched one of the signs. And so I know that this one cannot be the answer because there's no way that I'm going to get this 5a over 7b to equal -1 because they switched this one little sign right here. Okay, that means that my answer choice is just one of these three. And in these three, notice that each one of the first equations is exactly the same. So I have less work to do. All I have to do is find the slope of one of those things, and I can do that pretty quickly because we were just talking about how to do that mentally. So the slope of that line is subtract over this 10x, so it's going to be a -10, and then we would divide by the 7, so the 7's going to go on the bottom. So it's a -10 over 7. Okay, now what I've got to do is I've just got to multiply that times the slope of the second line, see if I get this 5a over 7b. If I don't, I know that those aren't the ones that are perpendicular. Just a second, there goes my voice. Okay, I think that's fine. Okay, so let's look at the slope of our second line here for answer choice A. Do the same thing. It gets a little bit more complicated because of this coefficient of the y, but it's okay. I think we can handle it. So I'd subtract over the a, so it's going to be a -a. And then I would divide by the coefficient of the y, which is a negative. Bring the negative with it. -2b over -2b. And I can see that these two negatives, of course, are going to cancel each other out. Boop, boop. So my slope here is a over 2b. Now let's just multiply those two slopes together. This product should be identical to what we had before if they're also perpendicular lines. So if I multiply these two things together, I get a -10 over 7 multiplied times a over 2b. Multiplying straight across here, I have a -10a over 14b. And then, I think I can reduce this. I probably could have reduced it before I actually multiplied my fraction, but I didn't. So I can reduce this by a factor of 2. So that puts a 5 up here. This puts a 7 on the bottom. And like I said, I could have done that at the beginning. I could have just divided this 2 into this 10 here to get the 5 up top. Okay, so anyway, this reduces to a -5a over 7b. Ooh, wait, is that it? Is that what we wanted? Ooh, it's not, because this is supposed to be a positive 5 over 7b, which eliminates answer choice A. However, what that does is it reveals what the answer is, because the only difference here is the fact that we have a negative sign, and we needed it to be positive. So all we have to do is look for the answer choice that has the exact same stuff in it, but then just has one sign difference, which is in fact answer choice B, right? Because look at the first equation is identical, but the second equation, the only thing that's different is that my y term has a coefficient of positive 2b. So whenever I divide it over to the other side, then I'm not going to have this extra little negative sign here. Okay, but let me walk you through it just to make sure that this is in fact the answer, and then we'll look at it with the slopes being negative reciprocals as a secondary way to verify the solution, because of course you'd have this much time on your actual SAT. Anyway, So let's come down here and find the slope of our second line for answer choice B. Again, I would subtract over the AX term, so it's a negative A, and then I would divide by the 2B, that's right in front of the 1. And see, this time the negative sign does not cancel out. And if I multiply that times the slope of my first line, which we said was negative 10 over 7, magical things will happen. Negative A over B, that's an A, and that should have been a 2B, multiplied times the negative 7 over 10. Negative 7 over 10? No, that's backwards. Negative 10 over 7. Okay. And now whenever I multiply these guys straight across, this time negative times negative will make this thing positive. And this one I'm gonna smarten up here. This 2 can reduce into this 10 before I even multiply. 2 goes into 10 5 times. Then whenever I multiply my things straight across, I get a positive 5a over a positive 7b, which is in fact exactly what we wanted. Check. Okay. Now let's look at it by just finding the negative reciprocal of one of the slopes and then generating ourselves some sort of relationship between that and the A over B and verifying that that's exactly what we get for answer choice B as well. Okay, so remember that we said that the slope of our first line here was negative 5 over 7, right? Our slope of our first line was equal to negative 5 over 7. So the slope of anything perpendicular to this should be the negative reciprocal of that. This one's already negative, so mine's going to be positive, and then I flip it over, and it should be 7 over 5. Okay, so this should be equal to the slope of our second line. We took the negative reciprocal of this, it should be equal to the slope of this second line. So if I take this 7 over 5, this should be equal to a negative A over B. Now, I can leave it just like this if I wanted to, or I could isolate the A over B by just getting this negative sign over to the other side. To get the negative sign over to the other side, I just divide it over or multiply both sides by -1, whatever. So A over B should be equal to a negative 7 over 5. Or alternatively, I can say that that negative sign is out front, it's with the 5, it's one of those things. Okay, so here's the equation that we have. Now, is there a relationship between this equation here and the one that we have up here? Absolutely. As a matter of fact, it is the same equation, it's just kind of rearranged. The way that I could show you that is if I have 5a over 7b is equal to -1. To get AB by itself, like what I have on this equation, all I have to do is get rid of the 5 over 7. How do I do that? I multiply by the reciprocal. So if I multiply both sides of this by the reciprocal, not the negative reciprocal, but just the reciprocal, 7 over 5, on the left side, these cancel out. That was the point of it. And I just have A over B left over. But I still have to multiply the 7 over 5 times this -1. When I do, I get negative 7 over 5. Oh, look at that. It looks super familiar. Okay. And then, if this is the way that you chose to do it, you would have to do the same thing for this one, for these two guys, and show that, again, you get this relationship that A over B is equal to a negative 7 over 5. So let's try that with these two things. Now remember that I already found the slope of this guy. The slope of this one was a negative 10 over 7. So we'll find its negative reciprocal. So I'll say the slope of our first line was negative 10 over 7. Its negative reciprocal is going to be positive, and then flip it over. So it should be a 7 over positive 10. Okay, and then I'm going to force that to be equal to the slope of the second equation. And we found the slope of the second equation as, it's down here, it's negative A over 2B. So let's set this equal to a negative, where is it again? I lost it, negative A over 2B. Okay, and now let's see if we can make this these two equations equivalent to each other. So first of all, I got to get rid of this negative sign, so it's going to come over here, and then I have to get rid of this 2. To get rid of the 2, all I have to do is basically multiply both sides by 2, because the 2 is on the bottom. Now, I'm going to do both of those things at the same time if I just multiply both sides by a negative 2 over 1, basically. Okay, so whenever I multiply this right side of the equation by negative 2 over 1, these negatives will cancel, and then this 2 will cancel out with this 2 that's on the bottom, and it'll give me my a over b that I was looking for, a over b. And then on the right-hand side, multiplying this side by negative 2 over 1, it'd be 7 times this negative 2, and then 10 times 1, it is negative 14 over positive 10. And then if I reduce that, I just reduce this by a factor of 2, I would have, let's see, a 7 up here, divide that by 2, and a 5 right there. Ooh, that looks like exactly what we were looking for. A over b is equal to a negative 7 over 5. Wow. So pick your poison. Do you want to do this by forcing the slopes to multiply up to negative 1, because that's what happens when they're negative reciprocals? Or do you want to find one of the slopes, find the negative reciprocal, and set that thing equal to the other slope? Either way, you're going to end up with answer choice B.